My name is Uwe HAASS, and I'm happy to be your moderator for everybody, not only for the speakers, but also for you, because I would like to get you involved in the discussion. The topic is pan-European projects with citizen science combined. The background is, as I mentioned yesterday, to have a more inclusive role of robotics in European education and schools. Inclusive means not only from cities, but also from rural areas, not only from bright young people, also, let's say, slow learners involved. So how can we organize projects across Europe which help to identify a European community of youngsters, of students, but also involve as many people as possible. Go to the rural areas where maybe youth unemployment is very high. Maybe go to migrants, maybe include areas which have been forgotten. So this idea, no child left behind, no region left behind in the development of robotics and the opportunities for ICT and especially robotics to be included in projects which help to give us a European identity. This is the topic, and I'm happy to have a number of speakers with presentations on suggestions or ongoing projects. And as I said at the end, we are going to discuss that. We have only 75 minutes. However, if possible, we can extend this, because this is to be a future development. It is giving some sort of impetus and motivation to the European Commission, to NGOs, to any other organizations, European organizations, to go ahead and start a campaign for projects like that. So, as I said, I'm very happy to have a number of speakers who are giving us a very broad range of opportunities and possibilities. And in order to make it short, I will start with Andrei Dumitriu. He has already been visible before. He is from the University of Bucharest. He has been a founder of several labs and very entrepreneurship-like working in robotics. He is teaching classes and courses and he calls himself a public-private ambassador. It's because you are between the public side and the private side, organizing activities, organizing meetings. And I'm happy you have come here, and we are expecting a lot of interesting ideas from you, because you are someone who is traveling between different worlds, from economy to business to education in different parts of Europe. So, go ahead, please.
I would need the mic.
Yes.
Thank you, Uwe. That was the best introduction I ever had. So I'm humbled. I really am, actually. Hello, everyone. I have presented you today some projects that are already ongoing. Some of them I am involved directly, and some of them I only help the ones that started the projects. We'll see as we go on. But the bottom line, why I was very excited when Uwe proposed this to me, is because at the University of Bucharest we started robotics recently, and one of our topics, basically, one of the things we thought continuously was, how do we make this, especially on 3D printing side, how do we teach students in such a way that they will not basically print only toys or only simple toys, only basically static objects. Okay, so the general direction is that we want to help children and citizens learn robotics in useful ways, as I said, not just static stuff. We don't just want to teach technologies, we want to teach the entire stack, because, for example, you see the last part is finish the project. One of the things we noticed is that even students, they know how to finish 95% of the project, but they don't know how to deliver. And many times the last 5% is actually the most important one because it makes a difference between a useful project and a used project and one that's just an idea and just a story. Okay, and the idea is to take advantage of what everyone had as an input instead of forcing them to go in a predefined direction. So one of our partners is the Mogurele Research Institute, which is actually home to extreme light infrastructure. So it's the highest laser in the world, the most powerful laser in the world. But they also have a scientific campus, one of the biggest in Romania, with 2,000 researchers, focused mainly on physics, but on everything else as well, robotics included. And each summer they do this summer school where they propose basically a research topic, and they help children start from scratch on that research topic, and maybe until the end they will actually have some input regarding the research material that will be presented. So in 2018, it was launching a balloon for atmospheric observations. This was done from scratch, as you will see in a moment. And in 2019, it was monitoring the environment, weather, and pollution in urban areas, which is, well, it's a problem in many places, but in Bucharest, I think, is the second most polluted capital in Europe. I'm not sure about that one, we'll have to check, but it's quite bad. Yeah, and also we try to encourage them in all the fields, including entrepreneurship. I'm really focused on that because I think that most projects that need to be durable will need to have basically a business side as well, because if not, it's just charity. And when you have an economic crisis, those are the first that get cut, unfortunately. Okay, so the first project was a weather balloon. They had to design the equipment, or design maybe it's a bit too much said for the students, but still they had to take designs and adapt them for their task. They had to simulate flight paths. It is very important for projects like this that you think them through from the beginning, because if not, it's like you only get one shot. If it's done, it's done. They had to do the monitoring system, so to make sure the data that they collect is useful in some ways. Okay. The second project was an automated green wall. This was for efficiency absorption. For automated system. This is one of the classic projects, but for students, for pupils, because this was done with pupils between 14 and 18 years old. It was quite important. And one thing I forgot to mention is that at Mogurele there were two tracks basically. So they focused on two groups and they mixed them up. The first group was on excellent students, one of the best students that they had in Romania. And the second part was students from rural areas that do not have access to this usually. And they mix them up so that they can transfer the knowledge and the experience itself. This is actually one of my favorite projects. I was really impressed with it because they actually managed to print, to 3D print a microscope and actually use it in one of the research they were doing. Of course, it wasn't the main microscope used, but I was really impressed. And it's quite the result. They did a study of the microorganism afterwards, how they react when you expose them to different lights. And also, they use machine learning for automated detection. They were already advancing with this project, but it was quite impressive that they could 3D print from scratch a microscope. Okay. Another project was building a replica of the Mars rover. This is not just a maquette, or how do you say it? This is actually it's functioning up to a certain point. Of course, the quality differs, but you couldn't send it on Mars maybe, but it has the same systems that it had originally. Okay. So this was all with the Mogurele Research Center, which is quite advanced, and they are trying to build more and more knowledge, they are trying to increase the knowledge base of the pupils coming from before the faculty actually, and more than that, they are trying to involve as many people as possible, researchers, normal people, students, and so on. For example, they came to us needing expertise on the robotics side and on the artificial intelligence side, but they are working with many other actors as well. Okay, this is actually from Ana Maria Stanco, who couldn't be with us today. She has RoboHub, which is a robotics hub for children. The robotics hub also has 2 tracks. You can do paid courses, but also she has free courses for children from rural areas. One of the first programs that she started was Educație Digitală, which translates to digital education. This was quite a touching program for me because she basically went around the country in remote areas and tried to teach children technology. The idea is that children in these areas, some of them don't even know how to use a mouse. So they've never seen a computer before. That's quite, I was really amazed with that, not in a pleasant way, of course. And one of the things that it is important, I recommend that you all take into consideration here, is that, for example, in the beginning when we start programs, we go to big companies. So do you want to get involved in this or in that? But we tried something else and it was quite successful. We went to the employees as well, like your everyday programmer who maybe is not involved in a lot of stuff. Most of them were willing to volunteer or to donate in order to help teach children. A lot of them actually. We were quite impressed with this result and it is something that we plan on doing even further. And we have some projects on that as well. Another way in her classes, she also teaches civic education. So for example, here you can see the words are in Romanian, but the idea is that here you can see on the map the order of a document from basically when they propose a law, it goes through many steps, and these are the steps a law goes through until it is being approved, and after that applied in the society. So with the line following robot, you had to program it to stop at every point, and I'm not sure exactly of the project, but the idea was that she mixed the line following programming line following robots with civic education and learning about the laws in the country. Because I'm not sure how it is in your countries, but I think it's available for most that it's quite complicated. So if you really want to understand how a law is passed, you must really dig into that. It's not something you read a few words on it and understand it completely. Another program that was really good, so we focused also on girls' inclusion and on gender differences because it's very split basically in Romania. So in the cities and in most parts, after an age, the difference is not so high, but in the rural areas, it can be, especially in the lower part of the age. So basically, until, I'm not sure exactly, but until 10 or 12, they really do not have access to this, and you can see lots of stereotypes. So they expect to play with dolls and boys to play with cars, and but those are just some examples, of course. But once you show them this, it changed quite a lot because for this, we taught them 3D modeling, and after that, we bought some 3D printers with us. It was quite impressive what they did. So 22 girls learned how to 3D print and 3D model. So it was a very successful and touching project. Also, we started at the University of Bucharest. We started with our 3D printing laboratory recently. And we thought high and low how to teach students 3D printing. Because as I said in the beginning, we didn't want to encourage them to just build small toys or static toys. And one of the projects we thought about, and after that we found this, was that why don't we 3D print prosthetics? Because the idea was simple. If you're in Romania, if you're a child, if you're poor and you don't have maybe a hand, well, life is tough. Life is really tough. So why not help them? So we started with this, but we quickly found the Enable project, which is actually an open source project around the world that has lots of contributors to 3D printed prosthetics. All the prosthetics you see there are open source. You can download them. You can actually basically you download it, you print it, you show a picture, and after that you get a badge that you can print it. And you are put on the map, and if someone around you needs that prosthetic, he can contact you and you can print it from there. There are also volunteer maps, so maybe you want to print it, but you do not want to assemble it, of course. The beautiful part about this project is that everyone can join in. I'm not sure if you know, but 3D printers are quite cheap nowadays compared to what, I mean, the price goes down fast. You can buy Prusa, which is like the high end of hobbies, but between 700 and 1,000 euros, which can be quite a lot for some. But if you want to go for the cheap version of Prusa, basically the China counterfeit is, or the copy, not counterfeit, is like 200 euros, and it prints quite well. Yeah, so this is a project that everyone can contribute to. And the next step is actually trying to make them motorized. So at the introduction to robotics, we tried to think of ways we could help them not only, this is basically a mechanic prosthetic. So you move your arm, and when you do it like this, the arm closes, and you can pick up a glass, you can pick up a bottle, but that's its limit, which is still quite good for most people. But of course, it would be best if you do a lot more. I don't have in this presentation, but there's also Open Bionics, which does the next step, but they are quite expensive. So they have some technology that is open source, but the hand itself is like 1,500 euros. So that's not really, it's still not there for your everyday child. No, not for charity anyway. Another project in April is 3D printed exoskeletons for recovery. This is a little bit sketchy because the idea is good, but with prosthetics it's quite clear. So you're missing a hand or a limb or something, and of course you want a replacement. But with exoskeletons, it's usually you have a problem, you have a condition that can be fixed or not, and it is important to see if the exoskeleton will not make it worse. So this is mostly for education purposes, but if you want to go and actually print it for someone, it is important to talk with their medic as well. Don't do it on yourselves. Yeah, and the last part we are doing with another school is building scaled down version of industrial items. So for example, right now we are building a scaled down version of garbage sorter. It's about the size of this table, something like that, a little bit smaller. And the idea is that they learn 3D printing, they learn electronics, they learn robotics, they learn sensors, and they also learn how basically an industry factory works, because the principle is exactly the same. Yeah, and I think this was the last slide, but the bottom line is that there are a lot of useful projects that you can build, a lot of useful projects. I mean, if we have the time, we have 20 more. But, and I recommend that you go and help or maybe get involved in this as well, because some of them, as you saw, these are at the national level, but all of them can be scaled up to European level as well through collaboration. And okay, thank you very much. That was all from me.
Thank you. We have time for one or two questions. Maybe, yes, Steve?
Can everyone hear me from here? Yeah? Okay. Andrei, that's a very interesting presentation. Thank you very much. I was fascinated by this idea of bringing what you call best students together with students from a Roma community. So perhaps my question isn't really robotics related, but it's to do with that sort of the dynamics of bringing these two groups of people together. And what was the experience, very briefly? What insights did you get from that?
Sure. The experience was quite vast, because most of it was a positive experience. Because when you put them together working on a cool project, it doesn't really matter. I mean, everyone finds its place in a way. Everyone is good at something, and actually the people from the students from the rural areas, you can see, and this is available with people who come and barely study the subject. They have a different way of thinking, which sometimes translates in very interesting solutions. So most of the times it was a really good experience. Everyone learned a lot, and it was important for the really good children as well to understand that there's another side to society that they are not exposed to, and they learn from each other. But we also had, it is important that we also had in few groups some too high discrepancies. So we learned that we did this 2 times already, and the first time we learned that we must think them through and we must adapt as we go on, because if it's a too high difference between them and they do not have the synergy of the team, it doesn't really work well, and it's a downside for both of them. But that can be tweaked on the way, because the teams can be adapted. But it's important to look at them and not just put them together to do stuff. That's not always enough, not for everyone.
Okay, thank you.
Yeah, welcome.
My question is, what is your pet idea, your beloved idea, or your suggestions for a pan-European project? Which ones? Because you had about 10 suggestions, and maybe from your experience.
Okay, sure. I'll have to think about. I think the 3D printed prosthetics is one of the. I'm looking at, even in Poznan, I'm not sure if you saw, there are some students who have the 3D printed prosthetics. The idea is that this is something that changed a lot with 3D printing. This is something that Usually it was hard, it was expensive, it wasn't that good, and now it's actually really good, and you can print it at home and you can give it to someone, and you can learn a lot doing it. You use the latest technology. So I assume it would be that paired with the exoskeleton. For the exoskeleton, there's also a Exo from Zurich, but which is a really good direction, but it's quite expensive and it's not open source, so we need to find alternatives in that as well.
Thank you very much, Dumitriu, for your presentation of so many examples how to bring students and children together from different origin, actually, and how to get them involved. The next speaker is Beatrice Masala from Scuola di Robotica. She has been also involved in the previous debate on women and robotics. You have background in multimedia art, you have graduated in multimedia art, and you have become an educator with your, as I understand, specialization on inclusion and getting, so you're just the perfect speaker for our topic. So I tried to get the slides for you.
Yeah, thank you. Just a few images to show you the project. So I'm going to talk about this single project we have been working on for a while now, and that we are improving right now with the similar projects. It is basically an underwater rob, low cost and with educational purposes. We actually took inspiration from an MIT project.
Sorry.
From an MIT project. It's a similar rob, but we added some features and we developed some workshop to work with it. So this is the original project of the MIT, and we basically added this camera on the front and a light, and also we added an Arduino in order to connect the controller and to make it a little more challenging from the programming point of view for students. We were able to make different kind of activities. We worked with actually, I want to show this. Okay, we worked with classes, and we were able to actually make this kind of path. So we begin with the designing, the real designing. So we started out to create a structure that could actually float in the water, but not in the surface. Then with some classes we were able to build the rob. So every group could build a rob. And so they could see all the process from the designing till the final exploration of the sea. Then it was very useful to add this camera because we could actually see, we gave the opportunity to young children also to explore the seabeds, the local seabeds. This was a very interesting point because since we are located in a city on the sea, by the sea, we had the possibility to use this kind of rocks in different kind of ambience. For example, the coast, so very natural. We can work a lot on local animals, for example, and create some kind of activities like to follow some animals, to find specific animals. And also we could work in open water, so we work from boats, for example, and also in the port area. This allowed us to work on animals, or plants we could see there, but of course also on pollution. So we could see a lot of plastics, a lot of plastic pollution, and we realized how strong and powerful it is for a child to see this kind of pollution with his own eyes, because all of this was connected with a display. So we could see what the robot was actually recording in that moment. And this was very strong and useful. And right now we are actually improving this project. We're not building this kind of rob, but we are using this and showing this, and all the children are actually trying this and using this in the sea. But we are also promoting this very, very low-cost kit, even lower, because this first kit, this first rob is low cost, but of course it has a cost because and it's also a little bit difficult for children, younger children. So for younger children, now we are working with this. You can see the picture. The pipes are garden hoses, and we use 3D printed propellers and 3 engines, the little ones, and we could build this similar structure, and we can use it in the sea, but also in pools, for example, because of course, if we imagine to bring this kind of project in other cities, of course, you can use it everywhere there is water. And so that's it, basically. This last project was also this one. We actually were bringing it right now in many schools, and it comes with a general introduction about the sea, about the local sea, and about pollution in general. So right now we are actually working on it. It will start in next month. We already worked with it in school, but also in summer camps. It was very interesting. This picture is from a summer camp, and this part was very, very involving for children, and also entertaining because it was summer, so it was also great fun. I think that's all for me.
Thank you. Thank you, Beatrice. Are there any questions? Yes?
Hello. Has there been
We will repeat your question. Okay.
Has there been any interest from bigger companies for deeper sea exploration with this project?
Okay. I have to say no, because actually this is not the good tool for the deep explorations. But we actually have some interest for the educational project. So the low-cost project is now being funded because it may actually be interesting for many realities. This kind of rope can go in deep. It has, I think, 16 meters of cable. But of course, it also depends on the pressure, on how to use it, and so on. So it's indicated to work like in the discovery, to discover what's in the seabeds, and to actually get to know your local seabeds. That's something that many young adults and also adults actually don't imagine what's behind the underwater.
I have a question: how expensive is a robot? Because I know from Germany, at least a few years ago, there was every year an annual so-called water day, and all schools in northern Germany had one day where they went to the rivers and to the coastal areas to collect water samples. And they brought the water samples to laboratories to check the quality of the water. And this was all done, the results were put into a map. So hundreds, thousands of schools were involved to collect water samples at one day and to receive a complete map of northern Germany on the quality of water. Could this be possible for all Europe? How expensive is a robot in order to get a project across Europe where students, pupils, check the quality of the water or the pollution?
Something that I haven't said is that, of course, it can be improved in many ways. So, of course, from the technical point of view, you can use it to collect water. The cost, I actually don't know the cost of the single rod, but we can think about it's like these are pipes, hot sealed. So maybe the process of hot sealing would be challenging. And then there are 4 engines, and also all the part of the camera and the display. I think these are the most expensive parts. So depending on the cost of these, I actually don't know how much was the cost of this single row and all the others that we built. But I think it's not so high. Maybe the engines are the worst part, but they can also be recycled actually. So I mean, you can take specific engines. And for the joypads, I think we used the very regular PlayStation joypads. So I think it was, and the Arduino. But the Arduino was in order to make it challenging. So maybe you can find other different ways to do this.
So if I make an educated guess, it's between 250 and 300 euros each. So it's not more. It's a very inexpensive solution, I think. So it could be feasible for thousands of those robots being used for checking the water quality, as an example, across Europe. I think this is possible.
So, do you have the project online? Is it available to replicate?
Right now, not yet, but to build the Rover, you mean? No, it's not available online right now, but maybe in the future will be, since we are now improving it from the other point of view. So for now, this kind of project, we are not bringing it anymore in schools for now, but it could be something that we will work on again in relation to the other projects, so maybe.
Okay, any other questions, suggestions? Thank you again, Beatrice. Now, the next speakers are actually a double. Biljana Vicković, she's also better known as Biba, and Irina Tomić, both from Serbia. Biba is the artist, studied painting and got a degree in painting, and Irina is the historian in arts, fine arts. They have been working in education in merging fine arts and robotics, and have developed a very creative set of ideas. Some have been already implemented and realized, and we are very keen to learn about how youth and young people and education, and not only science education but also civic, social education combined with robotics and fine arts, what this has turned out in Serbia. So, thank you. I will again.
Yeah, thank you. Hello again. I'm Biba Vicković, and I'm an artist, as Uwe gave me introduction. You will find out today from our presentation some other approach, what robot can do actually in many multi-sectoral files. Actually, the type of the robotics for the artist, which can combine many disciplines, is a very unique tool, and some kind of this type of technology is actually something what brings us interactivity between the user and between the idea which he wants to present. Because this robot is not only for the function. The basic of this idea was come up only from the function. As the artists do, we come up first from the vision. What we want to present, which kind of vision, what we want to give. And the most problem in the art file actually is this contemplation position of the user with no interaction. So this is the project, like a first prototype for me to try to communicate with robot technology in the open space. What was like a more special challenge to do something in outside world, not only in the buildings or in kind of university environment and that kind of things. So I do have this. So this robot is socially useful on the first place. And it's customized for the environmental, social, and cultural impact for the human society. That was the idea how to approach on it. Okay, this way. Yeah. Also, this is kind of robotic work of art. I already explained this kind of the position of the user, which he wants to remove, wants to do something new, And then we gave the robot on the first place the function to tin recycling because it's kind of daily life, and that is something what we want to create on a different approach. So this is the first robot which we set up in front of municipality of Rača on 208, and the communication which robot doing with the children and with the other user is actually the fun way of interactivity. When you approach to the robot says, "Hello, do you have some candy for me? I'm so hungry." And then open the bricks. The kids drop down the cans in the robot, and the robot gives him a ticket, says like, "Thank you to take care about our environment, and come again." So that was really a fun way to try to make this kind of recycling process interesting. Also, this type of the robot have a solar collector, so it's kind of energy. He have independent energy sources. So that was the second educating approach for the user. The container, the underground container is made of 45,000 cans, and it's all the time, it's full of the cans, since now it's kind of 10 years after we set up the first robot on the place. So they really like this funny neighbor, and comes up during the summertime, put some flower on him, on maybe this New Year. They come up with the cap, they put the cap of Santa Claus on the robot, and they find a way to communicate with this robot like with friend. So they really like it. And also what we have on the mind when we build up this robot, it's position of the heads. The small one is for the kids, and the second one is for the adults. And that was very much important to us to build up these differences to make the kids a comfortable approach. So this type of the bronze work, actually it's artwork in the open space. It's a sculpture in the open space, but with the functions and with the new type of communication with the society. And actually, the next steps which he wants to take it is to build up a new artificial intelligence for this robot, and give him opportunity to learn about the dragon, about the stories from the city. So the main reason why we start to build up this kind of project is actually two different approaches. One is the artistic movement, and the other one is the technology, which have to be very much specifically built up, because this is the art sculpture. It's not the construction easy to move. So the challenge which we get during this work with the scientists, because this collaboration was between artists and scientists, and we thinking so much open. For us, there is no straight lines, you know, and for the scientists, it's very hard to have this kind of amorph forms and know the balance between the parts, and everything is different. So it's kind of painful for them, but we did try the best, you know. So it's kind of a learning for each other. Yeah, and then I want to say something about this vision, which is for me it was a dream vision. I saw the 4 dragons somewhere in space. Then I made this draft work for the example and started to think how to make it in function. And this is something what was made of like a friendly user for the kids, because the dragons are scary creatures. They are not so easy. You have to put a can. The kids from the 5-year age old have to put a can in kind of dragon brick, you know, so with the teeth and everything, and it was like, that would be the scary movie for kids, so we should do kind of softer version of the dragon. It would not be the scary learning about recycling, you know. So we find a connection between the history, mythology and anthropology, and my friend Irina we're going to make approach of all these disciplines and explain you the connection between artwork, technology, and all these Asian disciplines.
Hello everyone, my name is Irina Tomić and I'm an art historian, but I have a PhD in art history and I'm working on my PhD in anthropology and ethnology. I am also a teacher, I'm a professor on the IT Academy and the Contemporary Art Academy in Belgrade, so I'm dealing with education all the time and I'm trying to find some new ways to present everything that I'm teaching. Today I will talk with you about two main topics. One of them is the design of the robots. Last night we saw some amazing robots, but as an art historian, I have to say I was not so pleased with the design. I think that artists should be more involved in designing robots. I think that they can be more interesting, more beautiful, more much less scary, much less skinless, and it looked like that there are skeletons approaching to us. And I think that it is much better to have some kind of artistic approach. I will show you how you can, by yourself or by by the help with an artist, how can you find a way to improve the design of the robot. The second thing that I will talk about is about our improvement of the robot that Biba was telling you about. So, we wish to make a project that identifies historical, artistic, ethnological and ecological values to unite tangible and intangible cultural heritage using artificial intelligence. That's a very complicated task. But we wanted to make this robot to be a part of our culture, but also a part of the culture of some other cultures, especially, for example, we wanted to make it global, so we wanted to connect it with Aztec and Mesoamerican cultures. And the problem with Serbian dragons is that they developed, most of the myths developed during the Turkish occupation of our country, so we didn't have any artistic presentation of the dragons, but they're, we can say, most wanted and most amazing creatures in our mythology. And that mythology lives until up to date, because until the Second World War, there were in almost all the villages in Serbia few people who were exorcising dragons from the villages. Dragons are very important mythological beings in Serbia because they bring good weather. So the dragon is very important to us, but we don't have a presentation. So we wanted to stay in Balkans, and we decided to take Balaur. It's a Romanian kind of a dragon. It's polycephalic, it has multiple heads, as our does. And also it is connected with snakes because we have legless lizard, he is like a snake, in Serbia, and his name is Blubber. It's etymologically completely in connection with Balaur. So we wanted to make this kind of connection, and also we wanted to make it global. I will talk to you about it just in a few minutes. Also, what is very important is to use as much resources as you can. For example, in Romania, it was discovered this kind of prehistoric being. It's something like Velociraptor. It is named by Balaur because it was very powerful and very destructive and etc. But he also had feathers, which is very important to our next slide, because we made a connection between dragons and snakes and feathers. And that's how we wanted to make it global. So our dragon, when we do everything that we have to do with the container and everything that it has to be done to be mobile, we wanted it to go all around the world if possible, Europe first and then all around the world. So we were inspired by this kind of creature because it's feathered serpent, it's Quetzalcoatlus, that's the translation, and also it is a god of arts, crafts and knowledge, which is very important to us. Also, as you have seen, maybe, I don't know if you can see clearly, the eyes of our dragon are something between blue and green, and that is one more connection with the quetzal. It's a kind of bird which was very holy bird in Mesoamerican countries and culture, and the feathers of those birds were used in crowns of priests and of rulers of Aztec especially. Also, we were thinking why robot doesn't have any jewels. Why don't we make some jewels for the robot? So we have found that Aztec dragon had his own necklace. That's a very special kind of necklace. As you can see, it has very deep symbolism. It's the spirally voluted with the jewel, and it is connected with hurricanes and every kind of disasters that were very important to Aztec people. Also, it's made of the shells, and Biba made some kind of stylization for a robot, so it can be nice to see necklace around the necks of our dragon. Also, there is a connection with one more prehistoric being. It's Pterosaurus, one of the biggest Pterosaurus, which was named by Quetzalcoatlus, and it has very long necks. As you have seen, necks are very important to our robot because they have to be very long so the people can reach them. The other topic I would like to talk with you about is model that we wanted to present in our new approach to this kind of robot. So it's modeled on encyclopedias such as Wikipedia as an open collaboration project, and we wanted to create the world's largest database of dragons. So the thing is, the robot is an encyclopedia as well as a museum because it should contain every knowledge on the world concerning dragons, constantly being tweaked and upgraded, because with additional app we have that kind of application that we wanted to improve the robot, which is obtained after you put 10 cans into the robot. You get application for a mobile phone, and then you can have all the history and everything that Dragon already knows, but you can come back with the same application, and if you know something that Dragon doesn't know, you can tell him and teach him something like that. And accordingly, the robot dragon will come to be the most educated dragon in the world. So, thank you for your attention. That would be all from us.
Thank you both of you. I think this is a very inspiring idea. If you didn't catch it, Biba is the one who has had worked on the robot, which exists already as this can-eating robot and it's placed in front of one of the municipal town halls in Belgrade. So it exists. And the idea, as I understand, is to extend now the idea of this dragon into a pan-European or even worldwide project, because so many, all areas seem to have myths about dragons and stories about dragons, but they are so different. And how to use this for a school project, for example, to collect the myths and combine this now with mechanized, with dragons and with some sort of a quiz or whatever possibility of speech input, output, or coupons to have additional features, which may be interactions or some work to do or some problems to solve, whatever. There's an unlimited possibility. However, the fascination is to come up with something which is somewhat buried already. I mean, it's close to be buried. Only few people seem to remember what the stories about the dragons were. So sorry for interpreting this to.
Yeah, no problem.
Are there any questions or suggestions how to cooperate with this project?
Yeah, you're there. Come on.
Is it mobile?
The more Biba explained, I guess the mobility is limited because of the tank for 5,000 cans.
Yeah, but we can make this. We can make also this underground bunker a smaller one. So do the press for the can, and then it would be possible to move the dragon around Europe. What would be the idea for these pan-European projects? So he can travel around Europe from the one place to another, pick up all this knowledge, and as Irina says, would be the most educated dragon robot on the world. So we are going to give him so much knowledge about our history and anthropology and that kind of thing. So I think it's a nice idea to have this kind of a robot.
Yeah, that was. Thank you. Yeah, that was my question. How big is it and how much does it weigh? So just
it's bronze.
It had a 1,050 kilo. It's a bronze 100. Yeah. Sorry. Sorry. Wow. And it's a bronze work, and the bronze is quite heavy. We will probably try to exchange this because of movement. We want to do some kind of movement of the net, especially the last one, which gives you a ticket. And we are going to put some kind of light material. But all those problems are so complex, so we want to do and build up the new prototype. And I think it's not that much heavy, so it's moldable. Yeah.
Yes, please.
I have a suggestion for more interaction between people and robot.
Mm-hmm.
You should add into the application AR, as in augmented reality. So, say when the dragon gets new information, you could say have an alert or something that the dragon has learned, and say that it sends a message that bring me one more can and I'll tell you a new story or something like that.
That's a very nice idea. Thank you. So we will give you also the presentation who wants to leave us an email address or something, then we can stay in contact and exchange idea, because it's thank you Uwe for idea for this kind of workshop. It's kind of workshop for us, because we really comes up from the different areas, and it's not easy to make a communication, but all ideas are very good and I think useful.
It's a next step, maybe a dragon from Finland.
Yes.
Yes, as part of the project. Thank you very much. Very inspiring.
Thank you.
The next speaker is Krzysztof Kurowski, who is the director of the Poznan Supercomputing and Networking Center. And we have heard you already yesterday at the opening ceremony. You are also in charge of robotics projects for education.
Thank you for the introduction. It's going to be really a big challenge for me because I think I have only 10 minutes and the topic is really important for us. Again, I represent Poznan Supercomputing and Networking Center, but we are also responsible for the National Research and Educational Network. As I said already, we started with connectivity and core services, and today I would like very, very briefly and quickly go through some slides and share with you some best practices and lessons learned from the last around 10 years. What is the main motivation for us to work with schools? We believe that there shouldn't be any barrier between primary, secondary, and higher education. And at least in Poland, there are two different ministries for primary and secondary schools and for higher education. And we've been constantly discussing this issue that we should really engage researchers, including psychologists, pedagogists, medical scientists, to work with us and really come up with some nice ideas, nice scenarios, how to take advantage of the ICT in the education process. For you to know, it's a good opportunity also to mention these are also key milestones and key projects related to education. So I don't have time to explain details, but we started with digital libraries. We put online the whole curriculum and open educational resources online back in 2012. But the most important for today is the Future School Laboratory. It's not a project, it's a permanent physical space. It's a service that we constantly provide, especially to local communities, schools, local governments, and also decision makers. For you to know, there's around 5 million kids in Poland and half a million teachers. And the biggest challenge for us is actually to work with teachers, not necessarily with kids, because kids are really happy to work with us. Teachers, because the technology is changing so rapidly, we found quite a challenge to work with them, because they actually, especially for the early education, it's really difficult for them to catch up with so many tools, so many scenarios, and they are also restricted with the curriculum. Speaking about the curriculum, there was a huge impact in formal education in Poland, because Ministry of Education introduced back in 2016, as far as I remember, the basic programming skills in the official curriculum. And suddenly, all the teachers in Poland could use potentially robots during the first 3 classes for the early education, to mostly use robots to introduce basic programming tools and learn how to program thanks to the robots, because there are so many gadgets, there are so many basic robots that you can use, and there was a huge investment also from government. And so many schools in Poland are buying, robots today and having classes with robots. I will briefly go through some slides about the future school laboratory, but from our perspective, it's also important not necessarily to only have this space here in Poznan. We will start next year a big project, and we will have such a space located on 12 campuses around the country, mostly connected with technical universities in all the main cities around Poland. So we also believe in proof of concept and testbeds. This is just an example of an experiment that we've done with a school from Sweden, teacher for biology. She was located physically here in Poland, and the rendering part combined with the video streaming was located in France. So we proved that it is possible to integrate online services located physically around the whole Europe. And that was back in 2011. So since then we have improved even, we have access to even faster high-speed links and networks. And by the way, another big initiative in Poland happening now, the government would like to finish the project and have all the schools, it's in total 25,000 schools, all of them connected by high-speed network by the end of the next year. So the future school laboratory concept, basically it's a physical space to which we invite kids and teachers, or teachers with kids, so they can actually see how many different technologies they can use for different lessons. We have been working for more than 5 years with different experts, different researchers to come up with some initial reference scenarios. Some of those scenarios are actually demonstrated at the booth. There's a future school laboratory booth, so you can see some scenarios, and tomorrow we will have a short workshop. We will demonstrate how robots can be used for education. And I asked for some recent pictures taken from the future school laboratory space. It's not located at this campus because we wanted to be inclusive, so it's a downtown of Poznan. So our labs, for those of you who have visited PSNC, there are some security barriers, but the future school laboratory is located in downtown, and it's free of charge, easy to access, and open space. So we invite, I think, roughly 2-3 schools per day are visiting this space. And since we opened back in 2016, around 400 schools already visited this space. So I really enjoyed the previous talk because we believe that we have to work on the next generation human-machine interfaces, so fully interactive. So we are demonstrating new technologies, how they can be used for some educational scenarios. This is just another example of how we connected Sandbox, which is natural interface for many kids, but they can actually use this in many different educational concrete scenarios as a steering or visualization box. There is one of the big challenges that we have. We want to put robots online, meaning that we would like to use interfaces, even basic interfaces at the end, but then use robots in the cloud and work on some virtual environments, so people can learn not necessarily how to play with basic robots, but how to play with pretty sophisticated advanced robots, and we're using haptic devices and other control, steering interfaces. And on the other hand, remotely, they can actually steer pretty sophisticated arms. And we're building now a garden, so kids will have the remote access to this garden and can play and use different robots in a garden in some specific educational scenarios. The water scenario is quite interesting because I can simply envision, the same or similar concept that we can remotely steer some robots and anytime, pick up, some pieces of material, earth or water from a remote site. Games and gamification, another example of another interface. We also do believe in natural interfaces, so using the voice control and speech recognition. Some scenarios, virtual reality. We have some scenarios defined showing how the virtual reality technologies can be used in combination with other ICT and augmented reality. Thanks for pointing this out, because we also believe that augmented reality is also quite useful in combination with cyber-physical tools, extending or giving the additional dimension for interaction for end users. And that's it. Thank you so much.
Are there any questions on? We certainly would like to see the living lab or robotics lab, learning lab, and but this is next time. We come back to Poznan. We come back. I think this is wonderful. Yeah. Okay, so
there is one.
What is the time scale for this garden of robots? I mean, are you going to plan it next year or?
No. I just asked the same question. They both they are buying, pieces. The most sophisticated part related to robotics. They have already completed. So I think we will put, once we will have all those pieces, the scenario online, just to start the test.
Another question: is the weather going to influence it, or it's going to?
No, it's gonna be. There is a special space in the future school laboratory, also for plants and for. It's going to be internal. Maybe then we will extend, but as I said yesterday, we're going to have a huge space at the airport. It's outside the Poznan, so maybe we'll have more robots, more drones flying around in the future.
Amazing.
I have a question.
You have a question?
Okay.
Yeah, take this one.
This one. Okay, so it's quite impressive what you managed to pull off. How did you do that? What was the secret? So the entire, all the projects are.
I think that the secret was that we started a long time ago close collaboration with, as a part of Polish Academy of Sciences, we have been working quite extensively with different experts from different fields, and it was just kind of organic, work, less top-down, rather bottom-up approach. Many young students were involved, so a lot of enthusiasm from young people. And at some point, we have decided that we have a critical mass good enough to really create, the living labs and start serving this as a permanent service to communities in the region, in the city, and now we also would like to have a kind of network of such spaces in the country. And maybe this is an idea for a European to just connect, some spaces, because there's one in Hamburg. This is what I discovered quite recently. There are a few other, such spaces. There's in Finland definitely. There are two at least I'm aware of. So maybe we should have a.
I think this is a big problem. We don't know of each other, so it's very necessary to build a network of best practice and even those, including the communities and regions which are not yet in this network.
And just last not least, we have a famous dragon in Krakow. So if you bring it to Krakow, then we'll love it.
Okay,
Excellent. So the last speaker, Andrei Bunis, who is from the European Commission, and last but not least, of course, Andrei is working in a unit responsible for improving the economy, especially with the hypothesis of SMEs, if they are getting access to technologies and using technologies like artificial intelligence and robotics, but then it's, as I understand, you discovered there's a skills gap, and now we are interested to learn what is your unit planning to do, especially to help us in Europe to develop better skills.
Thank you all. Well, indeed, we have discovered there is a skill gap, mostly due to automatization and the increased uptake of technology. Yesterday we spoke about the need for European businesses and European industry to become more technologically competitive, to be more digitalized, and so on. Of course, this can only happen if both business owners and the employees of these businesses are aware of new technologies and they know how to use them. They know what to do with them, they know how to exploit them, they know how to improve their own processes, how to become more productive by using new technologies. Otherwise, it's just not going to happen. In order to make use of these technologies, you need to be skilled in them, you need to have the skills. Now, as concerns the labor market and the labor perspective, there are basically two big groups right now from what we can tell. The first one says that automation will cost about 80% of the jobs in the next 20 years. So this is the first group. The second group says they agree on the 80% part, but they don't agree on the 20 years. They say it will happen just a bit later. So the perspectives are very positive, as you can tell. In the same time, there has been growing inequality in the labor market. I mean, the famous Gini coefficient, the equality coefficient between people and between how much they gain, how much money they make. There are many important factors in this. There's taxation, there's redistribution of wealth, there's where the wealth is produced, and so on. But it's undeniable that one of these factors is technology. We can, for example, look at most of the big online platforms. If you take an e-commerce platform, we're not going to name them. What happens is that they take a fair amount of the added value from where the place where it is produced, which is the person or the company which commercializes goods, and it takes it and it flies it over the pockets of somebody who's buying a third island in the Caymans. This is what happens in a lot of these this type of settings. So the Gini index of inequality has been growing in the past 10 to 15 years as well. Now, this will have some repercussions on the quantity and quality of jobs. Intuitively, you can think so. On the quantity of jobs, until now, technology has not yet had a lasting or short-term even impact. If we look at what our lives used to be like and how people used to be employed before the first industrial revolution, and we look at them now, the rates of unemployment are maybe a bit higher now, but people who work are just as employed as ever. If you remember how it was 20 years ago when we didn't have smartphones or internet in our pockets, which made our lives easier and simplified many things, for sure, we did not have less to work, and now we don't have less to work than we had before. So, in terms of quantity, we don't know yet. It hasn't led yet to creation or destruction of jobs. What about the quality of the jobs and the quality of what we will be doing in the future? And here, this is where technology plays some sort of role. If you look at how, if you look at the technology and the skills needed to use technology, you will see that the people who have the high skills, the higher educated skills, they can command higher and higher wages, higher and higher pays. On the other hand, you have an entire strata of people with lower skills, for example, whose wages maybe they are growing, but in any case not as fast as the ones of the ones who have the higher skills. So again, there is a gap here that is increasing. This is important for Europe because 1/3 of Europe's labor force lacks even basic digital skills. You have 43% of the citizens and 35% of the labor force that don't have basic digital skills, which is using a tool like a computer or a smartphone, something like that, to most of its capabilities. We all know how to make a phone call, we know how to use WhatsApp, but apart from this, from the really basic use, and not even that in some parts of Europe, we don't have that many skills. If you look at how people are actually using phones, phones and all this technology around it, we haven't necessarily gotten smarter regarding the technology. The technology has gotten easier to use. That's how it happens. 10 years ago, 15 years ago, if you would have gone to one of those big fairs, technological fairs, like the Hanover Messe, the biggest industrial fair in the world, you would have looked at a smart system, for example, how to control a robot. You would have had an engineer, because there was a screen with lots of numbers going up and down and so on. Now you can control it from an app. If it's green, it's good. If it's red, push this button quickly because maybe it's going to do something. That's about the level of, so it's not that being surrounded and bathed in technology has allowed us to acquire skills about it, which is why it is important for people who are in charge of delivering skills and bringing skills to the employees and the employers to actually do something about it. Maybe this is not necessarily the European Commission's strongest role, because you might know that it's not education and curricula of schools and of the official education systems are not a prerogative of the European institutions, they are a prerogative of the member states. However, what we do and what we can do is to encourage and to support schemes that are that we deem useful and that are profitable in that sense. This is where the Robotics in Schools pilot project that I was also mentioning yesterday comes from. This is the perspective, because we are looking at how to bring robotics, how to put industry and schools together to bring robotics in schools. We find that this is very, very important. It allows people to not only, I'm looking here at the very young generation in the fourth, fifth row there, it's not only important to be surrounded by technology, but also to understand it, to be able to design it, to be able to understand that this is going to be a part of our lives and how to use it for us instead of being used and being mold our lives around it. In more concrete terms, what has this reflection led to? After this entire analysis, we have consulted also stakeholders, we have held conferences with people from the industry, people from the educational system, from ministries and so on, studies, surveys, you name it, we did it. One of the conclusions was, for example, that the United States also faced the same type of challenge, but they went about it in a bit more different way. A large part of higher skilled employees in the United States work also for the defense sector. The defense sector in the United States puts a lot of money into high-tech research. And so there's an entire, let's say, trickle-down effect that this technology comes and spreads also throughout the high-tech labor market. We don't have this in the EU yet. Maybe it will happen in the future, but we do have some other strong points. And so we came up with a vision for skills for industry, which covers 3 sets of skills based on the research that we did and on the learnings that we gathered. First of all, it's sector specific. There is, of course, a very useful side to everybody having the same digital basic skills, for sure. You need to use some sort of technology to get around, which is normally in any sort of environment will be needed to type on a computer, to use Excel, to use PowerPoint and so on. However, it is also undeniable that the most rewarding, let's say, and the most profitable also for employees and for employers is not to have somebody who knows digital skills in general, but somebody who knows the field, for example, manufacturing or robotics and so on, and then adds a layer of digitalization, of data analytics, of artificial intelligence above it. This is what also is good for the employee, because they are reskilled, they are upskilled, they learn a new thing, but it's also useful for the employer, because instead of hiring and firing the old batch of people and hiring new ones, you just go and reskill the people that you have. So we're going about reskilling and upskilling. Sector specific, that it's very important, it's very useful. This is where the most gains in productivity are. Then we're talking about, it covers high-tech and digital skills. So not only basic education in digital, but also robotics, advanced manufacturing, artificial intelligence, so very high-tech in very specific parts. And then, and also very important, and this is where also these sort of, what we see in these robotics in schools projects are also very interesting. This forward-looking vision for the skills for industry in EU, in European Union, also covers transversal skills, the so-called T-shaped skills, which are, you have the T-shaped, so you have in the vertical part, you have the deep high-tech skills, like you know very much in depth how to program something, you know how to code, you know how to write software, whatever. But these, the bar on top, are working together, delivering common unit project, soft skills like how to communicate your work, how to work with other people, and so on. And it's all these three specific points of sector specificity, high tech and digital, and also transversal skills, they're also found in almost all of the projects of robotics in schools which are in these 2 days. So this is why we are coming back again now to the Robotics in Schools project. And Uwe knows a lot about it because he drafted a very interesting report on it just last week, which we'll be very glad to share with you also if you're interested in it. We are pursuing this Robotics in School project. Again, I'm launching the invitation for the 23rd of January conference and workshop in Brussels. That's about, I can tell you more. There's also a very large brochure on the skills for industry. If you're interested, I can send it all. I think we can circulate it. Lavinia will help us circulate it to everybody if you're interested. It's fairly long. If you have any more specific questions, I'm glad to answer them.
I think we are very happy to hear that the European Commission has picked up this element which was missing. And of course, it's the responsibility for schools is not with the European Commission, it's with the communities and with the regional governments. But I know this is the situation in Germany. However, we have to do something. We have to do something, and we have to combine this with European unity and so on. So, are there any suggestions? Andrei.
Yes. So one quick question. So, what can we expect about the workshop on 23rd of January more exactly? So, what should we prepare and what should we expect from the workshop itself?
Thank you. Very good. It allows me to put forward the draft agenda that we've concocted for the event. So very, very appropriate. We will bring together industry and teachers mostly, but also other, let's say, actors in the decision-making process. So we're going to bring also the other services of the Commission, not only mine, which is Director General for single market, industry, and the small and medium enterprises, but also the services who deal with education and culture, the ones who deal with employment, the ones who deal with other parts of like the research centers, research and technology and so on. The idea is to isolate the elements that make a robotics in school project successful in order to be able to replicate it afterwards. To have this sort of like basic guidelines or just some basic steps for somebody who wants to start a project, so they feel that they know that there is a support structure somewhere. There are people who did this before. This is the way they did it and it was successful for them. And these are the people that maybe they should talk to if they want more information, if they find themselves in a block, if they have, for example, I don't know, if they have maybe a school administration that is not as open, or if they have some restrictions on a local administrative level, these sort of things. There are some it will be a very simple guidebook, let's say, a very simple product of this, but this is what we want to make it. It has to be replicable, it has to be accessible, it has to be easy to understand, easy for everyone to pick it up and to say, okay, I want to bring robotics in my school. This is how I like to go about it. And so we have these three groups of people. We're also going to have, of course, people from the ministry, from the education ministries. We just bring them together and they say, okay, we have done already a first part of this work. We did it a month ago in Ori, Finland. We had a smaller group, a seed group. We have some very general ideas, and now we refine them and we put out some product. And this is it.
Okay, then again, I guess I can come. Sorry? Yes.
Can I ask a question?
Just a second.
One question is, who is taking the major costs of the rescaling the workers? Whether that should be industry, whether that should be the government, first thing. And second question is do you have any calculation of the timing of how long it's going to take to have a critical mass of rescaling the people in order to fulfill the implementation of the strategy of 4.0? Thank you.
Okay, I'll first maybe answer the timing part because it's the easiest one to really answer. There is not necessarily a specific timeline. Of course, the strategy is called Skills for Industry Strategy 2030. So by 2030, ideally, we have reskilled, upskilled the bulk of European workers and European business owners. But one thing that is very noticeable with new technologies is that it is no longer the case. There's the cycle of them being renewed And in a specific field, for example, in robotics, today you learn one software, one programming language, then in 2 years it's going to be something else. Design websites again. Something was fashionable 2 years ago, now it's something else, and so on. So this cycle where technology is useful and a specific set of skills is useful, the cycle for this has become shorter and shorter, which means that the most successful people in the field are continuously learning. This is a continuous ongoing process. It's far from what was, let's say, at the beginning of the industrial age, when everybody learned to work with one of those mechanical looms, and then for 30 years everybody kind of used it. They were just minor improvements. Now today it's a loom, tomorrow it's a totally different machine, a totally different set of thinking that you have to go on and so on. It's a continuous process. So there's not, for the very end purpose of it, which is to have a workforce which is always skilled, there is no end in sight. It will be something that is ongoing. Now, who's bearing the costs for this? We've also have done some studies together with the consultancy. It's actually the PricewaterhouseCoopers. They put out a study a few months ago, last year I think. They looked at the costs for reskilling, upskilling somebody, people in the company versus firing and hiring. And it turns out that firing and hiring is about 5 to 10 times, depending on the field and the amount of money you have to pay different member states and so on, 5 to 10 times more expensive than just reskilling and upskilling your own people. First of all, because they know the field. They know what they're doing, they just need to bring some sort of added technology on top. Even in areas where technology is really transforming almost the entire type of work that you do, like accounting. In accounting, things have gotten much different in the past 5 years, and in the next 5 years they will change completely, because almost everything will be able to be automatized. Even there, it's important to know the basics of it. So you have some processes that are now done by the machine, but you have to understand what the purpose of this is. Why are you emitting a certain type of bill, a certain type of time, the legislation, all this kind of stuff? You still have to know them. It's useful to know the field. So it's cheaper for businesses. This is a strong argument. Then it depends. In some member states, you have these schemes that encourage reskilling and upskilling. Like in France, for example, there is the scheme. It's independent learning accounts. I don't remember how it goes in French. It's some complicated longer name. And then the idea is that you have basically a backpack of allowances. You have per year, if you're highly skilled, you receive 500 euro. If you're not highly skilled, you receive 800. So this is also something good. They also admit the fact that high skilled people will make anyway better use of these anyway. And then you have on a platform, you can contact a vast amount of education providers. I think the education providers number is about 50,000 on this platform, because they range from a very, very big variation of types of things that you can learn. Digital, non-digital, in your field, in some other fields, and so on. And the cost for this, part of this is paid by the states, but there are also common schemes with the businesses of how much they have to contribute to the entire scheme, to this entire backpack. Then also you have private companies that have their own reskilling and upskilling programs, like for example Orange in France. They've been going through a reskilling of their employees at a rate of about 20,000 a year or something like that, and they're going to be finished in 2020 or 2021. And they are paying for it themselves, of course, because it's an internal program. Many other big companies, they have this sort of project. So it's a very mixed thing. I'm not able to say who should do it or who should not do it. Certainly, all parties involved have some sort of vested interest in it. If this leads to a common understanding, even more the better.
Okay. We will see how much the Commission is going to pay.
We have about 100 million for this. For the
we have 100 million.
We have about 100 million for the blueprint schemes. Yeah.
Okay. So I think we had enough. I don't want to say ammunition, but we have enough arguments today for you to turn this into something which actually helps people working now on a shoestring and not really having any vision about sustainability. We need to have this as a sustainable program in all parts of Europe. Thank you for your interest in this session. I think it was very interesting, from education, artists, science, people science, citizen science, a lot of food for thoughts, how to develop this for your own projects. However, let's communicate, let's stick together, let's exchange addresses, and maybe, I hope so, Robotics is going to develop a platform or a way to exchange ideas and collect maybe background papers and so on. So because that is very necessary, and maybe as a service to DT Grow, where people can look up what's being done already. Thank you again for your interest, and I wish you a good afternoon and continuation of this opening. We are still in the opening workshops of European Robotics Week. Thank you.